Hello everyone. In today's lesson, we're going to analyze polynomial functions, which means we're going to find its domain, range, and behavior, turning points, zeros, and their multiplicity. So technically we're going to put all of our lessons from before together, and we're going to be looking at the graph in a complex way. So let's look at this given function f of x is equal to x cubed plus 6x squared plus 8x. We're going to start analyzing this function by graphing it. You may use Desmos or graphing calculator TI-84 to help you graph. So let's look at the table of value first. Take a moment, if you have a graphing calculator, to graph it, and then just jot down on the side a few values from the table. So we're going to pick some x values and calculate some y values for it. Let's start with -4, -3, -2, -1, 0, and 1. I picked those values because the y values corresponding to the given x values are fairly small, so we can fit it on the coordinate plane that's provided here on this page. So when x is equal to -4, the y value is 0. At -3 is 3, -2 is 0, -1 is -3, at 0 is 0, at 1 is 15. Take a moment to plot the points. -3, 3. Close enough. -2, 0. -1, -3. 0, 0. And then we have 1, 15. So all the way up, unfortunately it's off the grid. Let's connect, since the leading coefficient is positive and it's odd degree, the end behavior, the graph is going to increase from left to right, and it's going to pass through the given points. So you have to make smooth curve almost without lifting the pencil off. So this is my polynomial function, and then we're going to, based on this graph, we're going to get different information. We're going to start with the parent function. The parent function is a cubic function, x to the power of 3, x cubed. The end behavior, we started, so we're going to be looking at the left end. The left end is when x approaches -infinity. My function f of x is going to approach -infinity as well. But then we're going to look at the right end. When x approaches +infinity, the function value is going to approach on the right +infinity. This is end behavior. Then we're going to be looking at the zeros. The zeros are located at the x-axis, where the graph is crossing the x-axis, and you can probably spot them and label them. So the first, we have 3 zeros at -4, and you can look at in the table. Then we have at -2 and at 0. Those are my zeros. -4, 0, -2, 0, 0, 0. Zeros happen to be when the y value is 0. And since the graph is crossing the x-axis at those points, all of them have multiplicity of 1. The domain and range. The domain, remember, is all the x values from left to right, and the domain is all real numbers, and the range up and down is also all real numbers. Where the function is increasing and decreasing, we need turning points for that. So let's label the turning points. Here, this top point, we call it a max. The bottom one is a relative min. And we're going to just write coordinates of each point. So the maximum, we call it relative max, lack of the space, we're going to just call it max, is a point at -3, and the minimum is a point at -1, -3. Between the turning points, the function is either increasing or decreasing. So if you look at from left to right, the first piece is going up, which means the function is increasing on this interval, and also here on the right is increasing as well. So we're going to write those intervals using only x values, like a domain, starting from left to right. So the function is increasing from -infinity all the way to the max, which happens to be at -3, and then it's also increasing from the relative minimum at -1 infinity to the right, which means to positive infinity. The decreasing interval is between the max and the min, and it's right here, this piece. And this piece is exactly between max and min, and maximum is at -3 and the minimum is at -1. I only use the x values, never the y value. We're looking for at the domain, not the range. This example is for you to do, so take a moment, pause the video, graph this function on the coordinate plane, and then using a paragraph or a bullet point on lines, please write the description. Everything that happened on the previous example, you have to now list one by one and give it the correct description. I'm going to analyze this function, but don't watch it until you actually do it on your own. So I started graphing this function with the table of values. I use graphing calculator, access the table, pressing second and graph, got my values that I am able to fit except one -50, so we're going to ignore that value. And we're going to plot the points and then connect it with the curve just by matching it with the graphing calculator. So the first point is -40, -3, -6. I have my points. I'm going to connect them by looking at the degree. The degree is 4, which is even, and the leading coefficient is negative, which means my end behavior is going to be down and down. And I'm going to connect the points to make my function pass through all of them. Okay, this is a rough graph. And then I'm going to get many informations from the graph. This point right here has to be, it's touching it, not crossing it. Please make sure you have the touching point right there. And we're going to write. First of all, we have a quartic polynomial, degree 4. The domain is all real numbers. Sometimes we write it with interval notation from -infinity to +infinity. The range is not all real numbers. If you closely look at the graph has a maximum, and that's where it caps the range. So the range is going to be below about +3, which is from negative infinity to +3. Another way to write it, y is going to be greater than, or it's going to be less than or equal 3. And behavior. The right end. At the right, the graph is approaching negative infinity, and at the left end, the graph is approaching also negative infinity. Turning points are called min and max. We have two relative maximums. The first one is at -4, 0. It's my first bump from the left. And the second one is about, of course you can round it, 0.431 and 3.124. We have the relative minimum at -2.319, and the y value is -8.643. Zeros. The first zero is at -4, 0, and it bounces, which means there is a multiplicity of 2. Then the next zero is at -1, 0. The graph crosses the x-axis, which means the multiplicity is 1. And the graph passes through origin by crossing it, which means we have a multiplicity of 1.